traducción que la vamos a ofrecer en idioma español. ¿Estamos listos? Saludos, buenas noches. Mi nombre es Armando Causade. Soy instructor del programa de Astronomía para Aficionados de la Universidad Metropolitana, Centro de Estudios para el Desarrollo Sustentable del Sistema Universitario Ana Geméndez. Y tengo el placer de darles la bienvenida a este evento estilo Open House, estilo Casa Abierta que tenemos esta noche, que va a constar de dos partes. Primero, les vamos a ofrecer una interesante conferencia que estaremos realizando aproximadamente de 6:45 a 7:35, poco menos de una hora. Y vamos a estar ese tiempo aquí pensando. Luego, si las condiciones del tiempo lo permiten, ya después de las 7:35, 7:40, vamos a salir afuera. Repito, si las condiciones del tiempo lo permiten, tenemos un espacio reservado en el estacionamiento multipisos, específicamente el nivel más alto, la azotea del estacionamiento multipisos, en este lado de la carretera, lado oeste de la universidad. No el multipiso que probablemente la mayoría de ustedes usó en el lado oeste, no. En este lado oeste de la universidad. Lado oeste de la avenida Ana Geméndez. Quería mencionarles antes de comenzar que la Universidad Metropolitana tiene establecido el programa Astronomía para Aficionados. Este programa es conducente a una certificación profesional de educación continuada de 100 horas y de hecho estamos comenzando un curso nuevo, un ofrecimiento nuevo. Nuestra estrella el sol es un curso corto de 12 horas y lo más importante que tienen que saber, estos ofrecimientos son abiertos para cualquier persona del público, de la comunidad. Usted no tiene que ser estudiante regular para bachillerato, a nivel subgraduado, es muy fácil matricularse. Pueden obtener más información o pueden unirse, ¿verdad?, como participantes del programa, marcando la extensión 6351, y el cuadro siempre les pide que marquen primero el número 9. Van a contactar a la señora Jennifer Cruz, que está tomando la lista con nosotros, y ella pues les puede orientar o les puede tomar su matrícula, que se puede hacer por teléfono, ¿cierto? Se puede completar todo el proceso por teléfono. El martes la semana que viene no, la semana siguiente, en poco menos de 2 semanas, comenzamos un nuevo ofrecimiento que es el curso Nuestra Estrella, el Sol, que se va a reunir cada martes en la noche, en sesiones de 3 horas, hasta completar en 4 semanas, pues 12 horas. Así que a través de la extensión 6351, marcando primero el 9, se pueden comunicar con Jennifer Cruz, que ella les puede ofrecer toda la información. Bueno, como parte de esta actividad, nosotros queríamos traerle una interesante conferencia sobre qué ocurrió con el planeta enano Plutón, ¿verdad? ¿Qué le pasó a Plutón? Y para esa finalidad, pues nosotros estamos aprovechando la visita del profesor Muhs, a quien voy a presentar en unos instantes. Y esta actividad pues va a ser también complementada con la observación con telescopios. Junto con la Sociedad de Astronomía de Puerto Rico se han traído varios voluntarios con instrumentos que van a estar en la azotea del multipisos. Les repito, si las condiciones del tiempo lo permiten, pues vamos a tener la posibilidad de observar la Luna y el planeta Marte. Saturno quizá con dificultad, es posible que ya esa hora se haya ido, está muy bajito. Vamos a intentarlo, pero no puedo prometer nada. Pero sí la Luna está bastante bien ubicada y el planeta Marte, pues aunque se está alejando de la Tierra, pues todavía tiene una altura considerable sobre el horizonte y podríamos observarlo. Así que, bueno, sin más preámbulos, paso a introducir el conferenciante que tenemos para esta noche. Y por respeto al conferenciante, pues yo quiero hacer esta introducción en inglés, para que comprenda cómo lo estamos introduciendo. Ladies and gentlemen, it's a pleasure to me to introduce you to Mr. Eric Muhs. He's visiting us from Seattle, Washington, and has been teaching astronomy and physics for over 30 years. He's very knowledgeable. He's going to offer a lecture on the topic of what happened to Pluto. He really enjoys lecturing on this topic, and basically his visit here in the island, the Puerto Rico Astronomical Society brought him, and he will be staying until Friday, and it's a pleasure to have him here. So ladies and gentlemen, please let us welcome Mr. Muhs.
Voy a hablar en inglés, pero entiendo español y si tienen preguntas, se pueden preguntarlos en español. Armando can translate as well, and we'll just do our bilingual thing. Mi esposa es mexicana y in order to get married, I had to learn to speak Spanish, but that was over 30 years ago, and I admit my Spanish has gotten a little worse since I moved to Seattle. When I lived in California, I was very good, and I taught in Spanish, and I was bilingual, but I dropped off a little bit. But I really have enjoyed being here, and we have some other things to tell you about. But I thought I would start with this, and we will look at this again at the end. This is a free software that I love. It is called Worldwide Telescope. It is free. Usually it doesn't crash quite as much. You've seen it crash twice, and that's why it came over here. I was restarting it. Maybe it has to do with updates. But I'm going to talk about Pluto, and Pluto, its orbit is this white line, and that is really different from the other planets. If the whole solar system is like a pizza, Pluto's orbit is like this, and it even goes inside Neptune. In fact, one of the labels we give to Pluto now is a trans-Neptunian object because it is crossing the orbit of Neptune. That's part of why Pluto got demoted to a dwarf planet. So we will look at this again, but let me just take this and tilt it in various ways. Oh, that's nice. And I can zoom in a little bit, and I can go to view, and I can start to speed this up. We're now running 1,000 times real time, 10,000, 100,000. Outer planets still don't look like they're moving. Now, barely we have the inner planets moving. I think I'm at like, I lost count, 10 million, 100 million times. And now we start to see Pluto move. But anybody know how long it takes Pluto to go around the sun once? Okay. I think it's about 250, if I'm not mistaken. Any? 250, 248? Anybody have a backup one? Long time. How's that? Yeah, ridiculous long time. But it's a very odd object, and when all we knew about what was out that far was Pluto, well, we called it a planet, because for a long time we didn't know anything else about that region. It's very, very far away, and objects are not that big. So I'm going to just pause that, and we'll come back to that, and I'll bring up my my regular presentation. Oh, but I promised, before I even got started on Pluto, I was so excited to talk about Pluto, I have other news. Does anyone here like meteors?
I do.
So maybe you knew about this already, but I just read about it today in the Guardian newspaper. So presumably they got it from some other science journal. But it was announced today that
they have discovered a meteor crater in Greenland under the ice, 19 miles in diameter.
Okay, I'm moving there.
19 miles in diameter. That's one of the 25 largest craters on the Earth. And it's only about 12,000 years old, which is very, 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 very recent.
It is very well preserved.
Yeah, but it is under the ice. So the way that they've actually figured this out is by waiting for minerals and material from the impact to find its way out to the coast under the glacier. And they figured this out. It was a meteor that was 1 mile wide. You know about meteors. How often does that kind of thing strike the Earth? Hardly never, and it's a good thing. Yeah, brand new. Check it out. Was that worth waiting for?
Yeah.
That's actually really,
Especially
yeah.
when you're telling me that there are shock minerals over there.
There's other news too. Do you want to mention yours? Because you thought that the news you had was the news I had, but the news you had was a new Earth-like planet around the nearest star to Earth, Barnard star. Yeah, they found a planet. Super cool. And it might actually be a little bit like Pluto. Who knows? But let's get on to Pluto. Or as I learned on the elevator up here, in Espanol se dice Plutón. Yeah, I learned something. So the question is, what happened to Pluto? Nothing happened to Pluto. Pluto is fine. It is doing today what it did yesterday, what it did 10 years ago, what it did 100 years ago, what it did before humans ever walked the planet. It's doing the same things. It's just that we have reclassified it. Someday we will reclassify you, and instead of being in 6th grade, you will be a high school graduate or a college graduate, right? It's still you. And that's what we've done with Pluto. So Pluto was discovered in 1930. Are we going to have a party in 2030? A Pluto party? Yes. So we've classified it for as a planet for a long time, but in 2006 it was reclassified. Just reclassified. Nothing about Pluto changed. But we reclassified it because we found other objects like it, and it was clear it deserved a class of its own. If anything, we elevated it. I'm going to propose that idea. Had to show this. Last night in Armando's astronomy class, someone who made the cookies? Media. And is that a Pluto cookie? Yeah.
See it? Wow.
I was going to suggest he pass it around, but I don't think he wants to pass it around. I don't think he's worried it might not come back.
It will not come
But
back.
what a beautiful,
Para la clase.
an amazing bunch of cookies. I didn't get to see them all, but the Pluto was really beautiful. And part of the reason it's really beautiful is that they did such a good job of making this heart-shaped feature on Pluto. Of course, we like hearts on anything, but to see something like that on a planet, fabulous. Here's how Pluto was discovered. It was discovered by a not very high-ranking astronomer named Clyde Tombaugh. He worked at the Lowell Observatory in Arizona. And this is what you did if you were not the most important astronomer. Picture of the night sky from January 23rd, 1930. Picture of the night sky 6 days later. The word planet comes from the Greek word for wanderer. The planets have a different motion through the sky than the stars. The stars all seem to move together, at least during the course of our lifetime. Of course, if we live to be 1,000,000 years old, we would gradually not recognize the stars from when we were young, because they do move, but they're so far away that we don't see them moving in our lifetime. But planets move in our lifetime. And this object right there, Clyde Tombaugh would look at two pictures like this, and the machine actually went on, and it's called a blinker, and you would look back and forth, blink, 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 blink. Is there anything different that has changed between those two pictures? And almost always the answer is what? No, nothing changed. Can you imagine doing this for 8 hours a day? Can you imagine doing it for 5 minutes? Not even, no. Incredibly tedious work, except if you discover a new planet. Then we remember you for a long time. In fact, that heart-shaped region on Pluto is now called the Tombaugh Regio. So it's named after the discoverer of the planet. It's very fitting. Very difficult work. By the way, is this the kind of work that computers are really good at? Comparing two pictures, looking for a pixel that's different. Oh, computers love this. And astronomers love computers for that reason. Just a word about this place where Tombaugh worked, the Lowell Observatory in Flagstaff. This is the observatory out of which all of that stuff about, you know how Mars has seasons and canals and ancient beings that live on Mars and all that stuff, all of that came out of the Lowell Observatory. And Lowell made these maps of Mars with these canals, and imagine Martians transporting their crops on the canals, and no. Kind of gives you a good idea of what you can dream up if you squint your eyes and look real funny through a not great telescope. So here's Pluto, another picture of it. Very, very, very tilted. And it's sort of hard to do, because if we think of the solar system as starting from a cloud of dust and gas, just like, has anyone, aside from me, ever worked in a pizza place?
No, but I've done pizza.
Have you thrown the dough? I knew how to do that at one point, where I could start with a ball of dough and actually throw it, and the physics makes it spread out in a disk. And that's essentially what the solar system looks like. But Pluto has got something else going on entirely. It's really an oddball to all of this. The rest of the planets are tilted maybe a couple of degrees, but Pluto not so much. We have sent a probe to Pluto. And in fact, Armando and I were teaching together in Wisconsin the summer that the New Horizons spacecraft arrived at Pluto. An amazing, amazing piece of business. We have sent other things out that way, but New Horizons was specifically designed to go to Pluto and see what's there. And it took a long, long time to get there. And if memory serves, I think it's the fastest moving object humans have ever made. Even so, it took a long time to get there. Wow. So here's the mission. It was launched from Earth in 2006. Which means, when did the planning start for this? About 1990, 1985, somewhere in there. And in July 2015, Armando and I are in Wisconsin, and we're teaching about it, but you have to take the clock way back. Some people were planning this decades ago. How big were you in 1990? Yeah, I know. Just an idea. So, when New Horizons was launched, it actually, they plan to fly it by Jupiter, where it goes, because Jupiter's turning like this and New Horizons goes past it like that, it actually gets sped up. Jupiter gets slowed down by that. So we stole a little bit from Jupiter to do that. So we flew by Jupiter. Got all the way out here. It's so far. Here is the New Horizons spacecraft. It's covered with a kind of mylar aluminum foil. We're very worried when we send these spacecraft about even a stray speck of dust, because the speeds are so fast. This thing hits a little grain of sand, could take it out completely. So we try to protect these things, and we imagine what's the worst thing that could go wrong. We try to build in all kinds of redundancy, not just one computer system, but 2 computer systems. But we were talking about this. By the time you actually get the thing launched, is all of the equipment that you put in it obsolete already? Yeah. You launch it with the very best stuff. Oh, Windows XP just came out. We should use that. And by the time it gets out to Pluto, everybody goes, oh my God, our thing is using Windows XP. That's so crappy. How can we even keep it going? But that's how these things work. So there's a guy named Mike Brown who was in charge of all of this Pluto business. And he says this, and it's not just him, but how does this all work? We need better classification schemes, and this is true throughout science. I mean, we start with birds, and then we realize not all birds are the same, and there's some birds that don't fly, and maybe they need their own group, and then there's the birds that look like chickens, and then there's the birds that look like swallows. And so he says this about planets. It has to be spherical. In other words, it has to have enough mass to squeeze together under its own weight and become a sphere. It has to be the main thing in its own system, and it has to clear out its own orbit. Pluto has a moon, and the moon is really big compared to Pluto. So for the Earth, when the moon goes around the Earth, moon, as the moon goes around, the Earth wobbles a little bit. Well, it wobbles because there's a system here. It's a little bit like, you throw a tennis racket or a hammer. It spins, but it kind of appears to wobble. It's not just the Earth pulling on the moon, but the moon pulls on the Earth too. So there's a wobble there. But for Pluto, the moon is so big compared to Pluto, Charon, its moon, that Pluto, the dance is more like this. They're not equal in mass, but they're equal enough in mass to the point where Pluto actually wobbles a lot. And that seems to be an important distinction. It's not that big compared to its moon. In fact, sometimes people even call it a double system or a double planet, because it's unusual that way, yeah. And Pluto does not seem to have swept everything else out of its orbit. And these seem to be disqualifications. If you'd like to read more about this, I have this book. I was going to bring it, I just couldn't find it. But he's actually a very, very funny and down-to-earth writer. I recommend his stuff. And he's got a website about all this as well. So here are the dwarf planet rules. And now we call Pluto a dwarf planet. Okay. It's in orbit around the sun, not around another planet. It has enough mass so that it squeezes itself and becomes roughly spherical, but it has not cleared its orbit out of all the other stuff. It's not around another planet. This actually repeats. I'm a little confused by that, sorry. But for contrast. Okay. So here goes New Horizons. And New Horizons did not take this picture. Nobody took this picture because we're outside of New Horizons. But it's an artist's conception of what this is going to look like. Pluto and Charon. I wonder if are we able to turn off some lights here? It might be good to. ¿Las luces? No es posible? Okay. Well, I would recommend, if you are interested in Pluto, you now have the opportunity that we did not have. We were very deprived growing up because we just had fake pictures of Pluto and nobody knew what it looked like. And now we do. We've got amazing pictures of this super interesting object. There's Pluto. Here's an even more detailed view of its surface. We had no idea, and it has turned out, and this is a theme in astronomy, we talked about it last night, every time that we have found a new way to look at something, we have been completely surprised. And Pluto, as much as any other thing that's happened in the last 10 years, has been full of surprises. What is it? I have a question for everybody. What makes weather happen on the Earth? What's pushing the atmosphere to make weather? Heat. Where is the heat coming from? The sun. Without heat, you don't get weather, or at least it seems like you shouldn't. I've been to the far north. The very limited weather, no thunderstorms. I've been to the South Pole, like Armando. It's cold there, but there's really no weather. It's the same every day. Same. There's weather on Pluto. There's an atmosphere. It's very active.
I can see a desert with a lot of dunes over there.
Yeah, I think that's part of the Tomball Regio. It seems like it's
That's one.
that area.
And it's very particular of a nearby mountain range.
Do you know what that's made of, this white stuff?
What? Ice?
Yeah, what kind? Not water ice.
No, methane?
Nitrogen.
Wow.
Nitrogen ice. And some of it,
That's very cool.
some of it seems to be deposited by the atmosphere. You know, sort of like you open up your freezer and there's ice that's landed on the frozen food. Kind of like that. It's active. Now, there's an awful lot we don't know about Pluto. How long did New Horizons stay at Pluto? It did not, here's Pluto, it did not go, oh, cool, and take a lot of pictures. That's one kind of space mission you can do. But New Horizons was going so fast that in order to get it to slow down, you'd have to carry a whole bunch of rocket fuel. So the whole mission was, yeah, it was close to Pluto for realistically about 24 hours. That's it. And it's headed out to look at other things now. But it had to go really fast to get there. If we'd sent it slow so it could hang around for a while, we would get old and die before it would get there, you know? So that's the choice. So there's a lot we don't know about it, but it has been just full of surprises.